with my laptop. That's why it has not shown that what you want to do, unable to find the hill device. That was the earlier case when I was running in the virtual environment. When you guys run on your laptop, it will show that what you want to do. Then you have to load your model in the virtual hill environment. But this is not in my case, as I'm having the device available with me. So I'm just simply loaded my model in the Typhoon Hill real-time simulator, that is Typhoon Hill 402, which is available with me right now, the 4 series. So this is basically the SCADA panel of that corresponding schematic. So as yesterday you have gone through the basics and the fundamentals of Typhoon Hill. So we are having in this case the one the schematic, that this is the schematic, and another panel is the another window is the SCADA window. So what is happening in the SCADA window? Likewise in the MATLAB or any other software, when you design any model, simply you can place the scope and you can observe the wave format there only. But we are having a beautiful graphical user interface, and we will show the observed waveforms and everything, the voltage and current in our SCADA panel. So what is happening here in the in this panel, we are having the PV panel, which consists of the PV monitor. It will show you the IV and PV characteristic of the PV module. Then we are having the battery voltage. Now how to get all this, and where to find, and how to link it with the schematic, that I will let you know after this demonstration in the boost closed loop. Step by step I will go for the designing in the boost closed loop example, but here in this case I'm simply just demonstrating the model. So for that, what you need to do is, very first of all, we are having the model controls with us, and for this, the PV, very first of all, the PV is there. In the PV panel, it is asking for a file to load. So just click on the load PV. When you click on the load PV, the we are having some of the files that have been designed and available in the example folder of Typhoon Hill, that I will let you know, that you have to go into the Typhoon Hill examples and inputs and photovoltaics. You will find these files. So I am loading, say for example, this file. Yeah, this is the file which I have loaded now. And the illumination, say for example, I have taken 1000 at 25 degrees Celsius. Okay. So these are the basic settings which I need to do when I am before running the SCADA of this. So I have run the schematic, I have loaded the SCADA, and in the PV setting I have loaded the PV file for this. Now what we need to do is, we have to simply run the SCADA. Now, as you are able to see in the PV monitor, the I and V, the variation of the I and V is available over here. The power is showing at my cursor. You can observe the efficiency also. Okay. Now, here, if you come in the section of battery and the power, it is displaying here in front of you. But as you are able to see, the discharge current is coming 0. Okay, fine. What the logic we have implemented in this, when you again go back to the schematic, as you are able to see here, the logic which we have designed, like if the output voltage is going up to this voltage, this battery voltage, if battery voltage reaches to 52, see, the charging will get stopped. Okay, so we are waiting for this voltage to reach up to 52. Then you will automatically able to know, yeah, the charging will get stopped. And now it is 50 point something 74 or 8, like it is approaching to 51 now. As it will reach to 52, then the charging will automatically get stopped. Then after this, we will provide the discharge path. How we will provide a discharge path, that I will let you know. Let first wait for this, let it go up to 52. Yeah, it has touched to 52, and the charging got stopped, and everything is got stopped, and you see are able to see battery current, PV output power, and everything is become 0. Now as you are able to see here in this schematic, there is an option of the contactor which provide the discharge path. So for providing the discharge path, let me again go to this SCADA panel, and when I click on it, when I both of my contactor, yeah, now you are able to see that the discharging is taking place. Okay, now when it reaches to 49, when it reaches to 49, the charging will again start. It is 49.706967, yeah. When it reaches to 49 exactly, then I'm not doing anything, it will automatically, the charging process will get initiated. Let's observe, it's 49.2119, yeah. As you are able to see, yes, when it reaches to 49, the charging is automatically started. It has started the charging when it reaches to 49. So this is the logic which we have incorporated here. This is the example model of Typhoon Hill, and they have taken the upper limit and the lower limit as 52 and 49 respectively. Now what you need to do, if you want to do any modification in this, if you want to change the limits, or you want to design your own controller, and you want to make any changes in the plant, so you can make in this, you can make the changes in this. But I strongly recommend you, for making any changes in the example model, better to copy that folder, example folder, complete example folder, in your working folder, then make the changes. Then make the changes at n number of times, but please don't make the changes in your example model. It might create you problem, the settings got disrupted for the existing example model. So for that, I am just telling you the way how to copy that particular example in any other folder. So before going that, I would like to ask, if you have any doubt, you are welcome to ask, like in schematic or in SCADA. Otherwise, I will let you know the process of copying the example, how to copy the example. Then after that, we will go for the design and simulation of the another example. And better to keep one thing in your mind, like this C function. This is the heart of this example. In this, we have implemented the perturb and observe algorithm here. And in this exam C function, only two tabs are coming: journal and function. For another target of our is the advanced C function. So there are two additional tabs, and you will get to know by yourself only what is the exactly difference between the C function and the advanced C function. Okay, so here we have just incorporated the simple perturb and observe algorithm. We have designed the algorithm. I have shown you the SCADA is running properly in front of you, and the discharging and charging logic which we have incorporated in the schematic is simply redirecting into this SCADA panel. So if you have any doubt, you can ask me, or allow me to go on the further step. Dear participant, kindly respond. Okay, am I audible? Okay, okay, fine. Fine. So let me stop this simulation. Yeah, one thing I was telling, uh, no, how to copy that example. Let me tell you. Simple, you have to go into your my PC or my computer, whatever. Then go to C drive. In the C drive, you need to go into the users. Then this is my folder, and you must having your folder with your name. Then you have to go into app data, roaming, and Typhoon. This examples, the models. Yeah. So the category of all the examples displaying in front of you, and here the general power electronics, and there's a folder of MPPT boost charger. Complete folder you can copy, Control C and Control V wherever you want to paste. You can take the photograph of this path as it is displaying on your laptop screens. okay, so that you can have any of the example in your working folder. So in this fashion, you can copy any of the example and you can modify it, but don't make any changes in this particular folder or in the existing example folder. So if you are done with this, and if you are able to know the whole glimpse of the MPPT boost charger, then let me switch to the another model. uh, we need to design as per the schedule. There is a boost closed loop advanced C modeling and simulation is scheduled or targeted. So let me take you on the designing of the model in the Typhoon environment. Okay, so again I am telling you, just close it. Yeah, once you come on this is TSCC, that is the Typhoon Hill Control Center. On this Typhoon Hill Control Center, for designing any new model, you need to click on this schematic editor. Okay, once you click on this schematic editor, then you have to open a new file new n- new model. Yeah, and as yesterday ma'am has told you about the settings and all the like device table, so I am not going through this again. We are just designing the model. Say for example hill 402, and the hardware configuration id is 1, and this is the device table. Now exact auto, okay fine, next. Just click on the finish. After doing this much of changes, or the initiation I should say, there is a blank window. The blank window will come in front of you, and in this only you need to the design. You can design a new model. So before going to a new model and before designing a new model, let me show you what I am going to do. So let me give you an idea for this. Again I am going into the examples, and in the power electronics, general power electronics, there is an example of boost converter with closed loop control. This one I have opened. This example, one more example I will open. Oh, yeah, I will open one more example. How to example and advance. Yeah, yeah, this is another example. So, dear participants, kindly try to understand what I am going to do in the next 1.5 hour. Say, for example, this is the schematic diagram of boost closed loop control, and these both are very similar, and you will gonna have exactly similar results in both the models. But what makes the difference in between the two is, say this is the boost closed loop control, and this blue portion, this one, this is the controller of this boost closed loop. Okay, so what do we need to do is, we need to design this controller in the advanced C function. See this one, we are going to design this complete model. This one we are going to design, and here we are having the advanced C function. Okay, in the MPPT boost charger we were having the C function, and here we are having the advanced C function. After reaching to advanced C function, I will let you know what exactly the difference is the between the C function and the advanced C function. So here I am just telling you again, once again, this is the controller of the boost closed loop, and that we are going to design in this C function. So I hope the object of my another phase is clear to you. What I want to do and how I'm going to do that, I will tell you. But what I want to do, the object should be clear to each and everyone. Then only it will develop the interest for you guys. Okay, fine. So this is what I'm going to design. In this is my new like schematic file. Here I'm going to design the same. So I hope everyone has opened this new file on your laptop screen. Okay, okay, fine, thank you. Everyone has opened. Then let me move again to this. Fine. So very first of all, we need to have a like for designing this I'm saying I'm going to design this. So as here this is the V input. So for this I need to have a input voltage. So for that I will take a constant voltage with me. Then for this I have to go into the sources. We are having a voltage source with us. This one, just rotate it in this fashion, and yeah, keep it constant 0 0.0. Now like name it as v in. V in, enter. Yeah, this is the voltage source. Now for this, again what I need to have, I need to have some passive component with me. So I need to go into this passive component. I want one resistor and one inductor with me, like this. And of course I need to have a boost converter with me. For this you have to go into the boost, like this, drag and drop the boost converter. Okay, so what I need to do is I have to connect all these. So before connecting this, so I would like to have a one current measurement and the voltage measurement with me. So for this I need to go in the measurement, and I'm taking one current measurement and one voltage measurement. Okay, so like in this I need not to make any changes. Yes, constant 0, I'll make the changes afterwards. And I'm just naming it as I input, I in. Okay, and this is I'm taking as, let's say for example, RL. Okay, and this is L. And say for example the value of it I'm taking as 0.1. Yeah, and for inductor is 1 millihenry. Yes, fine, 1 millihenry. So now connect all these. Okay, fine. So the input side I have made till now. And again what I need to do is I want to have another current measurement with me. So this is a current measurement, and I'm naming it as boost, I out underscore boost underscore. Say for example boost, I have named it. Okay, fine. Then one resistor, here I am taking one passive component again I required, and rotate it. Say for example I am naming it as R. Okay, and the value of this is 0.001. I'm just simply replicating the example which is available in the Typhoon HIL library, Typhoon HIL example section, so that you can get idea about it, how to do the basic hands-on for this. We have taken the very generalized example. Sorry, I have to connect with one capacitor also. Yeah, the value of this C is, let's make it C, and the value of this C is say for example y810 e to the power minus 6. Yes, fine. Again, I need to have one current measurement. Okay, fine enough. This, and I am just naming it as I out. And one voltage measurement I require again. Rotate it and name it as V out. O U T. V out. Yes. Connect these two. I hope you all are drawing along with me. So this is the V out, and I want to take this signal out just for the feedbacks scenario. So just I will click on it, and in signal processing, I'm click on it and taking this execution rate as TS. TS is the execution rate I will define in the model initialization afterwards. Yeah. Then I'm requiring one more register. So here, one register, one more, rotate it, and one contactor I required. So for that, I need to go into the contactor, and I will take the single pole single through contactor. Yeah, here it is. Say for example, connecting for and disconnecting for the load. So now I'm making the connection again and completing my circuit. Just make the connections. This is a very basic and a simple example, and you will be easily understand. But the logic is to implement the that you know advanced C function. So let me insert the value for this also. 100 for R1 and 25 for R2. Okay, and this is we are taking as, yeah, detail input. No need to make any changes over there. And in this boost, just like take it, internal modulator, and the that time period, say for example, is 1 to the minus 6, and this reference signal is 0 to 1. Yeah, okay. This is what the changes we have made. And after doing this, we will be having two inputs came out, so that we need to insert some signal. So how we are going to insert that I'll let you know afterwards. So till now, if you have any problem, you can ask me in designing this. We have taken only the input voltage for and the current measurement with a resistance we have named as RL, and the inductor simply the voltage measurement and the boost converter we have taken, and we have made the necessary changes as per our requirement. Then we have the current measurement once again, resistance, capacitor. Then okay. So if anyone is lagging somewhere, or if you have any problem in finding any component in making the connections, kindly let me know so that I can repeat myself once again. Or if you are stucking somewhere, please let me know.
Excuse me,
Yeah,
please,
yeah,
what value did you put for R1, please?
yeah, yeah, yeah.
R1 and R2.
Yeah, this R1 is 100.
100, right? Okay,
Yes,
how
yes,
about
yeah,
R2?
100. And R2 we have taken 25.
Okay, 25. How about for the uh, S1, the contactor?
Yeah,
What
yeah, yeah.
you made some changes also
Yeah, the
on contact.
simple, you need not to make any changes. Simple, you have take the single pole, single through contactor,
Okay,
and yeah, and just keep it same as likewise.
Okay, how about the capacitor 810, right?
Yeah, the capacitor is 810 microfarad, 810 E minus 6.
Okay, but the initial voltage is 0.
Yes, yes, correct.
And then there's one place you put TS.
Yeah.
Why,
TS,
why?
yes. Here. In the V out,
AV or TS
signal processing,
override signal.
and just not override signal. Just click on the second tab, signal
Yes.
processing.
Okay, signal processing. Okay.
Yeah,
Okay, then I put TS.
yeah. Enable signal out. Just check it on,
Oh,
and
okay.
just put TS. Okay.
Okay, TSR. How about the uh, V?
Input. This
Yes,
one.
VA1.
V in.
Yes, no,
Yeah,
VA1. Yes.
yeah, 0.0 till just keep it like this only, then I will let you know how to insert the value. Okay, just
No,
keep
I
it
mean, for the V out, you put TS.
yes,
Are we
yes.
going to put for VA1 also TS or no need?
No need, nothing. It was just here only because you are taking the signal out for this, so you need to mention the TS, and nowhere you need not to mention. Okay.
Okay.
Mm.
Is there any
So
changes on the this thing also on the boost or no
boost,
changes?
yeah, there are changes in the boost. Yeah.
Like what?
Click on it and just go to internal modulator.
Okay, internal
Mod,
modulator.
yeah, then you need to change in the dead time, just make it 1, it is 5e minus 6, just make it 1e minus 6.
Okay, 1E-6.
And take the reference signal, like it is -1 to 1, take it from 0 to 1.
Okay, from 0 to
Reference
1.
signal. Yeah.
Okay, 0 to 1.
Yeah.
Okay, thank you very much, sir, for your time.
Okay, you're most welcome. Then nothing changes, like RL is 0.1 and V input line. uh, yeah.
Because we want to get the same result with you so that we
Yeah,
can
yes.
go ahead.
Yeah, definitely, you're
Yes,
most welcome.
very
Yeah.
much. Now
So
everything.
this is, yeah, this is the plant part, which we have done. Now just go to the advanced C function. Okay, how to go into advanced C function? uh, Either you can simply type the advanced C function, or you can go into this signal processing function and table, and there is option of advanced C function. I'm again repeating myself: signal processing, function and table, and advanced C function. Okay, so just go to that and click here. And, you can make it large as per requirement. Now we need to do uh, some changes, some important changes in the advanced C function. So how to go with that? Just come with me. Before that, I would like to tell you to save this model. And before saving the model, what I would like to tell you, say for example, let me tell you. Yeah, I have make one folder. You please, you also make one folder in any of your drive. Say for example, I have made a folder Boost Advanced C. Okay. Yeah, I have made this folder. Just please make the folder. Then I will tell you what you need to do in the next. Once you done with this folder, once you're done with this folder, say for example, I have made Boost Advanced C. Then what you need to do is you have to go into my computer. Again, you have to go in that example section, and you have to copy two folders. Why we are copying these two folders, I will let you know.
Okay, we
So
go to my computer.
yeah, my computer C drive
Okay, C drive.
and users,
Okay, users.
and there must be the display, like mine is Dr. Salim Kwabs, so your folder must be coming by your name. Then there is app data. Have you reached to app data folder?
Are we going to the Typhoon HIL or what?
No, after user you have to go in your the name of your computer. Then you have, after going into, there is an option of app data. Are you able to see
Is it
app
in the
data?
C file?
Sorry.
Now I go to the C file, then what again?
See, let me tell you once again. C drive. Okay, come to C drive.
Okay,
Yeah, double click. Go to users. Double click on users.
yes, users.
Then there is, this is the name of my computer. Okay, what your computer name is, just there must be the folder displaying with your name. Is there anything like so?
I cannot find that folder.
Oh, can you please present your screen so that I can see? I'm stopping my screen. I'm just unsharing
Okay.
my screen. Yeah, I have unshared. You please present your screen so that I can help you.
Okay.
Yeah.
How to share the screen?
Yeah,
It
there is
will
option of share screen, open share tray.
only meeting organizer and presenter can share the screen.
Okay. So you can't share it.
No, no, no. He can share. No issue.
Acha. Okay. Please share. There is a option, fourth option, open share tray. Are you able to find this option, open share tray, so that you can share your screen?
I think it's saying only meeting organizer and presenter can share screen.
Okay.
Presenter can share the screen. No issue.
Sir, I'm sharing a screen, and
Yes.
actually the participant want to share. I mean, is he able to share his screen so
Because
that I can?
first I go
Just a
to
minute, sir. I
first I
will
go to
close it.
file.
So, are you able to find the sharing of option?
Vivek sir, are you there?
Yes, we're there.
Sir, actually,
AP.
when performing hands-on modeling for rectifying the errors, we would be requiring so that participant can also share their screen. So could you
Okay.
Yeah,
I
yeah.
will check.
open
I
that
will change.
option for all?
Okay, okay. We will do it.
Yes,
Just
sir. Yes, sir. So that we can find out the errors they are facing, and we can rectify.
Sir,
View background line.
hello, sir.
Yes,
Sir, in my case, it is showing like component is not available due to missing requirement, advanced C function.
it is not showing.
It is showing component not available due to missing requirements. SIL support toolbox something.
Okay. License, the training license you have incorporated the training license. Which license you are using? We have
First,
provided the license, same license you are using.
so there was two license, so I downloaded two, but
No, no, the license provided to you by Vivek sir. That license you have to use.
uh,
Yeah, then only it will come.
okay,
Meanwhile, you can do that license issue that you can go and change the license there in the activation key. Put that particular activation key which is sent by Vivek sir. It will hardly take 2 minutes and then again restart your software. But before doing this, please save your models.
Let me tell you. Here is the option of license. Click on the license and change license, and
okay, sir.
yeah, put the license key that have been provided by the Vivek sir.
Sir, can you send again, sir, that license?
That it is
please,
available, Vivek sir.
please check your emails. I have already shared.
Oh, okay, sir. Okay, sir.
Please check your inbox.
Thank you, sir.
Alim sir, I think you should continue when the sir will open the options for
Yeah,
all.
yeah, yeah. Yes,
Then
yes, yes.
we will rectify, we will take them individually,
Yeah, yeah.
otherwise,
We will take you individually, so because it is taking time. So yeah,
because it can be done from the only host control,
yeah,
we cannot do in
yeah.
this.
Is my screen visible, ma'am? Khushbu ma'am.
Yes, it's quite
Okay,
visible.
thank you. Thank you. So, what I was telling, here you have to go into the this folder which is named in your computer. Click on it. Again, go to app data, roaming.
So I can share my screen now.
Okay, okay. Please share.
Okay, this is the screen, sir.
Yes, yes. Share it.
Okay, this is my screen now.
No, it is not visible to me.
Okay, let me again. Okay, let me cancel again. Okay,
Click
let
on
me
the
do.
fourth option,
Yes.
and yeah, and then there's one desktop type of icon is coming at the down. Just click on it and share it.
Yes, desktop window. Then this is this. Now I can share. Okay, can you see it
Yes.
now?
Mm, yeah. Yes.
So
In this,
this is my C file.
yeah. Click on it. Double click. Yeah. Yes. Go to user.
Okay,
Go to
user. This is my user.
yeah. Come down. Yeah.
Okay, I shall
Okay.
come
Wait.
down.
Yeah. Yeah. Wait. Default API public FKE admin. Just click on the third folder, like third folder
Okay.
FKE admin. Try to
Okay,
see.
this
No,
one.
I think no. I think no. Please go to your back to your this OS C drive. Back to
Okay,
your OS C drive.
this one C drive.
Yeah, above it is showing yes. Again, to double click on it.
Okay.
Go to your program files.
Okay, program files.
The two options are given. Program files that is given. And now search where have you installed your Typhoon Hill.
This is Typhoon HIL.
Is that showing? If it is not showing in this folder, then yeah, here it is.
So I should click now.
Yeah, double click on it.
Okay, then what again? I should check.
Then go to your model example. Yeah, example it is showing. Click on examples.
The last one. DSS under driver DSS.
Where?
This one.
After DSS, it is given the examples. They
Okay,
see example
okay, this
folder
one.
is there.
Okay,
Uh,
then models.
Open this. Then go to models.
Okay,
Yeah, models. Click on models.
Yeah.
Go
models.
to how to examples. Now, Silencer, I think now you can continue.
Yeah. Go to how to examples. The folder
What?
is how to
Okay,
example folder.
okay, how to example? Okay, click
Yeah.
already.
Now boost closed loop advanced C, very first folder.
Okay, I should copy, right?
Yeah. No. Don't copy. Just double click on it.
Okay, double click.
Yeah. Double click. Open it.
Okay,
Open it. Yeah. Just copy the first two folders. The first
okay,
folder, boost closed loop ARTW and the images. Copy.
okay,
Select two. Control C and paste it on your working folder. Any of the folder.
okay,
Yeah. Copy these two. Yes.
okay. I'll do that.
Control C, yeah, and minimize this window. Don't close this. Okay, just minimize this window and copy
Okay,
these two folder in any of your working folder. I mean, the folder which you have made in it at your computer.
okay.
Yeah. Okay, you got it.
Yes, this is
I
the
think
folder.
all the participants have got it. Like where to go in this and where to
Yes. So
copy. Yeah.
is that all? I should stop sharing now.
Now you can stop sharing and you please paste your these folders in your working folder where you are going to save your
Okay,
schematic
sir.
file.
Oh, okay, sir. Thank you
Okay,
very much,
stop.
sir.
Okay,
Thank you.
welcome.
Salim sir, if it is possible, you can show them before proceeding that C files in Notepad so that they can understand that from where.
Yeah. That I'll come on this. I'll come on this. Okay, just give me a minute.
Thank you so much.
Hmm. I've told. So have you changed the license? Like one of the participants is facing the problem in changing the license.
Sir, now it is okay, sir. I got it.
Okay, fine. So what I was telling is, yeah, I have made one folder and named it as Boost Advanced C, and I have copied these two folders as I right now as I have suggested. So I have copied and pasted these two folders in my working folder, and in this folder only I'm going to save my schematic file. Okay, so this is my schematic. Now I am going to save it. So for that, what I need to do is simple go for Control S. Either you can go for Control S, or in from file you can go save as. Okay, so I want to save it in this folder. Yeah, here. Then I am just copying this and path so that I can initialize this. Control S, and I want to save my file here, and I am just naming it as Boost uh, Advance C. Okay. Okay, now Boost Advanced C. Actually, I have made this one time file Boost Advanced C2. I have taken. because I've already made this with this name, I think. So Boost Advanced C2 schematic file, just click on it, save. Now, what I am going to do, and why I have asked you to do all this, just because, say for example, this is the model which we are going to design. We are designing this model, and this is also a closed loop boost, and this is a closed loop boost, but here we are using the advanced C function, and here we are using the generalized signal processing function. So for this, for having this general signal component we are having here, we need to have a C code, because in this example we need to have a C code. Here we need, it will ask us to load the C files. So how to get all these C files? For that, what you need to do, this is the controller. You need to, one way I am telling, the one way, you need to design this controller in the MATLAB, and after this you have to generate the C code, and that C code, generated C code, that C files, you have to, import in this advanced C function, in this advanced C function. Now the question definitely arises in your mind, that how to generate the C files. Many of you are aware that how to generate the C file in MATLAB, and many of you have not aware about the generating all this. So for this, actually, I have, that's why I have asked you to copy this folder here. So for this, what we have done here, not I'm not going to tell you about the, the generation of C code and designing the controller in the MATLAB. It will take much time. If you have if anyone of you have you're working on this and curiously want to know all this, so we can give you the extra time apart from this slot. So here, these are the generated C files. These are the generated C files, and this we have designed, this is available in the example folder, and that have been designed while designing the control in the MATLAB and generating the, you know that C code. So this is, there will be three files, like the main file and source file and the header file. So what comes under this source file, what is going inside this, that I will let you know once I am done with the advanced C function. What is going inside this, I will let you know. Let me complete with this advanced C function, then I will tell you line by line what is going on in this. So now, if you complete with this part, this advanced let comes to advanced C function, and just double click on it. And if you just double click on it, you need to make some changes here. That in the very first of all, there is an option of inputs. So just come to the input and come along with me, right along with me, and please take care about the capital and small letters, because if you are just doing different, then it will create a problem. So I'm writing v out underscore in. I am just initializing the inputs and outputs for it. So v out underscore in, click on it, you inherit again. If you want to add one more input, click on the plus icon and click here for reference, reference underscore in. Why I am doing so, I will let you know. Let's make it real null. Okay, add it. One more input you need to add. That's just pwm underscore enable underscore in. Okay, pwm underscore enable underscore in. Click and take it unsigned integer. Yeah. Okay. So this is about the input, and now let's come to the output. Again, double click on it, and output, click enable underscore out, click on it, check it, and this is some integer. Again, one more output I want to add, that is modulation signal. modulation underscore signal underscore out, and it is, take it real, is real assigned here. Fine, enable out. So fine, let me check once again and let me go to the input v out in. Okay, fine. So this is the inputs, outputs, and we need not to make any changes in the variables and parameters. Now we have to go into the function here. So in the function, we need to write a very basic code. Actually, let me tell you what I'm going to do. This we have taken like the in journal, we have to initialize the input v out reference PWM enable, and output is enable out and modulation signal out. So this we are doing for initializing the input and output of the advanced C function. And again, in the function, how they are linking with each other, we need to write a small, very small code of around 6 to 8 lines for initializing all these. So there is a command rt capital U dot v, v out, say for example v out. Okay, and that will be equal to this code is written in the example also, but I am, for your sake, I am just telling you how to do it. V out underscore in, then semicolon. Okay, then again one more input I will initialize rtu dot reference reference underscore in. Yes. Okay, then again one more, that is rtu dot pwm enable pwm underscore enable, then pwm underscore. If you miss with me, you can simply take a look in the example which is available with you, or you can ask me. Yeah. Okay, I will copy this code as well, and now I will just name the file boost closed loop closed underscore loop underscore control. This is the name of the file, that's that folder I am taking. Step. Okay, now we have defined the inputs, the name of the file. Now we are going to define the outputs, like enable we need to define enable underscore out, and here instead of rt u we will take rty dot enable. Okay, then the last is modulation signal out, signal out, then again rt capital Y dot modulation signal. Signal, and in the initialization function, again we need to write the name of the file. I'm just copying it from here. Just copy boost closed loop control underscore. Here we will make a change and we will write initialize. INITIELIZ. Okay, fine. And and we need not to make any changes in the update function. And In the DLL function also, we need not to make any changes. Now in this additional sources, it will ask to add some file. So for this, click on this folder, and it will ask you, just go to your working folder where you have kept your ER2W folder you have copied from the example one. Just click on it and select folder. I'm repeating again, click on this folder, go to your working folder where you have kept this that ER2W folder, and select folder, and okay. Then it will initialize here. Now when you click here, all the three files, C files, will come here. Okay, so we are done with this advanced C function. Now what is the next step? Just simple.
Excuse me, sir.
Yes.
Please now display this step. Additional sources.
Yeah. Click
Then
on
I
this
go
folder.
to add. I go to
Click,
close, right?
just click on this folder. Let me tell you once again. Click on this folder icon. Say for example,
Okay.
I'm deleting mine. Again,
Okay.
click on this folder.
Okay.
Okay. It will redirect you that folder where you have kept this file. I have asked you to copy these two folder now.
Yes, I have done that.
Yeah. Just go to that folder only,
Okay.
and single click on this boost closed loop current ERTW.
Okay.
Or click on single click and
Click
select
again.
folder. Select folder.
Okay, I click select folder. Okay, done.
Then it will come this.
Yes, I have done it also.
Okay, you got it.
Yes.
Yeah,
Got it
fine.
already. Thank
Yeah.
you.
Now just click on OK.
Okay.
Okay, there must be some error is coming. Uh, symbol errors must be coming. Signal and out. Wait, let me check. Hmm. There might be some error. Laptop. Let me check. Some initialization problem is occurs sometimes when click here. RTU V out. Okay,
So that
let's
is
check.
enable underscore out equal to RTY dot enable underscore out, sir. Seventh line.
Okay,
Seventh line.
seventh line. Let me check the seventh line. Oh, it is.
No,
It is like
dot
this.
enable.
RTU enable dot out. No, I will initialize it afterwards. But let me complete this. Enable underscore out is RTY dot enable is okay.
No, sir.
Uh,
Capital E, sir.
no, you are right. Actually, I that the thing you are telling now. I will
Yeah.
just initialize it here. Just check it here. That you are saying we will just make a change here. It's a small e. Here we will take a small e only. Okay, that I'll come later words.
Okay.
That thing you are telling now. This is the example
Okay.
when I'm showing. This is a small e only. We will take, but I will come to this afterwards. First, let me find the error which is coming in this. Yeah, it might be possible there is some case sensitiveness might be coming. Let me check from the scratch. Yeah, v out underscore in reference PWM enable in signed. Okay, fine. Now let me come to the output again. Enable underscore out. Yeah, and modulation signal underscore out. Fine. Okay. Now let me go to the variable nothing and parameter nothing. Now let me go to the function. There might be some problem in the function.
No, sir. We have to write same, right? RTY dot enable underscore out. In terms
Under
of out.
in terms of dot, you mean to say? Oh, it will come only dot.
Enable underscore out, na, sir.
Which
We
line?
have defined initially. Seventh line.
Seventh line. Yeah.
Yeah. RTY dot enable underscore out. Already we have defined that enable underscore out as a output. So here also we have to define same as RTY means output function only we are defining right here.
No, actually, this is actually syntax. With this, you
Okay.
need to dot come with dot. Just let me check once again. RTU dot v out underscore v out in RTU dot reference is equals to in PWM
Salim sir,
enable.
have you written the initial function?
Yes, ma'am.
Initial function have you written?
Yes, yes. Yeah, here might be some error. Yes, INITIA. Okay, this was the mistake. No, TIA.
Yeah,
INITIA. Is right.
yeah. Now
I
check your syntax.
no INI is right. INITIALIZE. No,
Check
Yes,
that
yes.
check
Yes,
your
sir.
it's
Yes.
already no, it's already fine. INITIALIZE. Boost
just
flow.
enlarge it. Just enlarge it little bit. Means that error I want to see. I think there is some comma or something.
Yeah,
Uh,
this is the only error. Might be possible. I am unable to detect the same
just export it.
output function. The error isn't coming in output function. Error 18 output function signal expected comma. This is a problem of comma and something in output function.
Yeah, maybe comma or dot. Please check with that, or
Yeah,
some
yeah, yeah.
space you have given irrelevant.
Let me go with this once
You
again.
can on the seventh line you can do the same. Just try that rty underscore enable.
No, I think this okay. If you are saying so, I am going.
Yeah, you
It
can
actually
just
is
try. Sometimes
no,
it
no.
happens like that.
Yeah, yeah, you are right, but it is not a syntax. So when you are
Sir,
writing it,
Salim sir, last eighth line there is semicolon
semicolon,
at the line 8.
Yeah,
semicolon.
you have
Okay,
to put the
okay,
same
fine,
because
fine,
we
fine,
are not
fine.
writing here in Python. This is C language. So here we need to give the
Yeah,
permission.
yeah, yeah. It's found. Actually, I have not placed the semicolon here in the last 8 line. Yeah, now no errors found. Thank you so much, Shamsher sir. Thank you. Yeah, the semicolon was missing in the the last line. We need to place the semicolon for terminating the statement. So we are done with this. When you are just working on it and you when you want to check the code, simply click on the check syntax. If no errors found, it means okay. Earlier when we were clicking on check syntax, the error are coming were coming. So now we are done with this advanced C function, and we have closed it. Okay, fine. Oh, what happened again? I think we have not made the corrections or what? Yeah, again semicolon. Okay, yeah, fine. So now, is this clear to everyone? If anyone have any problem till now, kindly let me know. Now we are going to add some signals like, say for example, this is the signal V out. The V out is coming from this. I am connecting here. Okay, and for this reference input, I am just taking a SCADA input from my library. So for SCADA input, you need to in the signal processing, you need to go into the sources and you have to take this SCADA input. Two SCADA input you require. First, I am just naming it as reference. I am just for reference. I am taking reference reference. Okay, and here I am just clicking and changing some necessary changes. No, there is no need to change real. I just want to say okay 160. Here I am just changing it TS. Okay, TS connected with this. Okay, and again I am just taking as PWM enable, and for this I'm again taking it as TS. Fine. And for enable out, now what here we need to take, uh, I need to take a signal tag, like why go to and from in the MATLAB. Here also we are having like a signal tag. For this I need to take some go to signal. So here I am taking one go to here. I want to send that signal and one go to here. So click here and name it as enable. ENABLE enable. Make it global and okay. Connect this here. And one more I want to take, that is reference global. Yeah, connected with this. And for these signals, these are the signals which are used to drive this the gate drive signals of boost converter. Here now we want to have some from. So here I will take one from here. Two I need. So this is what basically the reference and global. Okay. And one, this is the enable and global. Okay. And just connect with this and this enable with this enable. So this is what the complete schematic has been done. Try to save it. And for here when I go to initialization, just click TS. I am just taking TS. The execution rate is say 50. Right now I'm taking 50 microsecond. So 50 e to the power minus 6. Okay. So till now, if anybody has any problem, please ask, because we are already done with this schematic. And
So,
yes,
what
yes,
for the C function, you put scatter panel.
yeah,
What is the, you made some changes like on the reference.
yeah, yeah, yeah.
What are the changes?
It is same, like exactly same. Minus 1 e6, 1 e6 0, and the last execution rate just place TS.
Okay, TS. How about for the second one, for the
Yeah, yeah, yeah. Same,
PWM?
exactly same. Yeah, same.
Or how about
TS.
for the tag 1 and 2?
Sorry for yet this one enable.
No, for the go to
Go to one. Yeah, go to one.
go
Click
to one.
click on
Okay,
this enable.
okay. Is it
Enable.
local or global?
Yeah, global. Enable and global.
Okay,
Small. And for this also, reference go to two. This is reference and global.
okay. The first one, reference and global. Okay,
The second one is reference and global, and the first one is enable and global.
okay,
Okay. And likewise here in the from, on the top of the boost, you have to take the from, then reference and global. This is the from tag, and this is enable. Second one is the enable and global.
okay,
Okay.
okay. Understood.
Yeah. So
So
what?
one dot.
Yeah, yeah,
Sir, when we are writing this code in advanced C function, so you
yeah, yeah,
have used some parameters you have defined. So we have taken integers and real values.
yeah,
So
yeah.
a real value is like a float we are using in the C. The float is for the all the values is point, means all the decimals value and real value everything.
Yes,
So is this real value is similar to float that we are defining in the this function?
yes, yes. Yeah,
Okay.
yeah,
Okay.
yeah. This real to like to float. So this is like the schematic now. What we are going to do, what I am telling you, like just to let me come to the C files. The C files which we have just incorporated here in this folder. Now let me take you there and let me define you. Say for example, let me go to this folder. Yeah, here. Let me define you the brief of this. Double click on it. The very first file is the C source file. I'm clicking on it, and actually I have a compiler installed in my computer. That's a Visual Studio. So it is available and it is getting open in my laptop. But in your case, if you have any compiler installed, you can open it, or you can open in some other medium like Notepad and all. So let me tell you what we have done in this very briefly. I'm just telling you, then I will switch to my SCADA. uh, Say for example, line number 18 is the, the C file is like a C combination embedded C. Then this is the name of the folder which we have made, and this is DW RTW. It is initializing for the signals auto storage, and as I have used RTU and RTY, this is basically for the external inputs. External input means, let me show you this one. For this inputs and outputs, reference in and enable in. Okay, so this is for that. RTU and RTY we have used in that embedded, like in the advanced C function. And this code, I have not written this code, but actually what you how you can do this, you have to design your controller in the MATLAB. Just generate the C code in MATLAB, then these three files will generated. Save it in your working folder and call these files in your advanced C functions. So then this is again input RTY enable and RTY PWM enable. This is automatically generated with the help of the embedded C coder, and these are the reference. And we have used some integrator over there. So this is the command for the integrator, and like this is the basically code generated with the help of the MATLAB. This we have incorporated in this folder. So now let me compile this first and check, is there any error coming in the model. If it will error free, then we will switch to the our SCADA panel. Otherwise, if any error will come, then we will rectify the same. Okay, so let's check out for the errors. The model is getting compiled. Yeah, so now our model is error free, and there is no errors found in this. Now it is now I am again not connected with my real time simulator, and it is asking me unable to connect to the hardware device. So what you will do, again you will just click on this load model to virtual hill. And once the model is getting once the model get load on the virtual hill, you need to create your SCADA. So now let's come to SCADA very quickly. We have only half an hour left. So the SCADA is very easy. We will take the important widgets in this. And so for that, what you need to do is just create new panel. Yeah. Once you come on the create new panel, very first of all, what you need to do is you have to take this image here, just click on this image, and I need to place one image actually. So what I need to do is double click on it and select image. So hello, so select image. So what you need to do is in that folder only where I asked you to copy this folder, images also. Okay, there is a folder of images. So just double click on it, or we need to incorporate this image over there. So control C, I'm copying the path and going again here, select image, pasting the path here, and this image will come. Open it. Okay, now this will come in front of you. This is nothing but simply the screenshot of the schematic which we have drawn. And likewise, why I am doing so, that I will let you know, and you will easily understand this. And send, right click on it and send to back. Okay, fine. Now what I need to do is I need to design a controller for this, boost control for this. I am interested in taking the group widget with me. Yeah, this is huh? This key is not visible. Wait, why? I have presented. I think after some time is this. It is coming now. Coming now. Coming. Not coming. Yeah, yeah. Okay. Actually, after some time, it is automatically going. I don't know. I'm not doing anything.
Yes, yes, I will come in. I will come in.
Yeah. So now I have to take this group widget, and for this group, what I need to do is just simply click on this group and change its name with boost control. Okay, and place one LED over. I want one LED to be placed here. So click on LED, and how to just give the command. Wait, actually I forgot to place one component over there. Here, yeah, let me go to back again schematic. Here I need to place one digital probe. Yeah, digital probe. Click here and connect it to enable. Okay, and name it as enable. Okay, enable control S, and again run it so that it can visible over there. No, I'm just running it again. Now it will automatically reload it to that particular SCADA. Yeah. Now here we need to select the signal which we have placed. Say for example, we have taken the probe and we have given that name as enable. So double click on it, and I want is its color. It should be in green. So okay, green, and make it green. And the signal, digital signal, I want to take as enable. So click on the enable, and the signal will go into this. It will operate according to this. Now after this, what I need to have, I need to have one combo box with me. So here I will drag one combo box, and with this combo box I will just give the command, and click on it and making it as enable.
I will tell the
After making it is enable, you need to mention like enable and disable. Just name it as enable, and just I want to give it as disable, and another is enable. Okay, and for this you need to go into the edit in code editor, and in edit in code editor you need to give this value like this. This is a in this widgets we are having the two options. Either you can create a Python code, or you can directly go with the another option like inserting with this. So here there's a format of that particular command, how to edit it. I am just writing here like if input value, it is written case 1, so we are writing is enable. If input value is enable, okay, then for this what you need to do is I need to give the command for that. Here there are option of inputs, okay, like SCADA input, and then in SCADA input I will go and just drag it like this. there is a command of pwm enable and insert it like this. After you insert like this, it means the hill that's set SCADA input pwm enable, I want it to get enabled at 1. Okay, and again for this case 2, for disable, I want it to get disable when it is 0. This, yes, when pwm enable is 0. So here we have given the command save it, and okay, just for this you need to go in the advanced setting also, click on start and make it macro and save it. So these two are done. Now let me go to another widget quickly, that is the reference voltage. For that I need to have a knob with me, and I am just naming it as the reference voltage, reference voltage, and I want a value should be taken from 40 to 100 with the step 1. Okay, and for this again I go to into edit in code editor, click here, SCADA input value in the reference, click here, and that hill.set SCADA input value reference, but I want it to change with input value. Yeah, yeah, this is done. Okay, again for this, yeah, make it large and click again, go to advanced, on start and make it macro. So this is basically the boost control option. We are done with this, and now we are having some another important widgets. Say for example, I want to have two gauges with me. So for that, this one gauge is there, another I want one more with me, and for this the very first one I am just naming it as v out, o u t v out, f5, and the analog signal decimal places 2, and take here v out like this. Yeah, and its value I want to take it 0 to 100, fine. And another I want to take for I out, for I out the limit I want to take is from 0 to 5. Okay, and signal I want to take as simply I out ampere. Yeah, fine. So V out, I out is done. This boost control is done. So let me come to this one capture and scope I want. So for this, yeah, I need to add some signals in the capture and scope. Say for example, yesterday ma'am has shown you about the inverter. So for this, just click on this and add signals for the capture and scope. Like if you want to add signal, say for example, very first of all I want to see capital the capacitance, the C. Then again I want to have the inductor. Yeah, wait. Then I'll click on the inductor. Then I just click on it. Then I want to have a VL. Say for example, V out, V in, and V out. Okay, I out, boost I want to take. Oh, fine. Okay, fine, this much. Okay, done with this. Close it. Now only few widgets are remaining. The one is the contactor SCADA. We need to add the contactor here. Yeah. So take one contactor over here. I think it's contactor. So for that contactor, your wait, the combo box I will take. Okay. Contactor settings. I will just name it contactor state. And in the contactor state, we will add two cases. The first is the open, and the second is for close. Okay. And now again, we need to go into the edit in code editor. And for this, like for the case of the open, what I want for open, uh, again the same procedure I am going to adapt. There is option of contactor setting, and in the contactor setting, simply insert this code, and it will show hill.set contactor load. Yeah, we need to make it uh, true in both the cases. Let's just do one thing. Again, I want to check it here as W control, then insert. Then it would be better that we need to make it true always. And the first state for open, need to make it false. And for another case, for the close case, for the case of close, again we need to insert it and just make it true state. It is make true. Yeah. Save it in the API. So this is the contactor state, and with contactor I want one LED also. Say for example, just dragging and drop. Yeah. And I need LED here. Just click on it. Say for example, contacts UNT, and signal I want green, the digital, and this load underscore FB. Yeah. Okay. Now I'm done with this contactor state also. This LED, the two gauges done, boost closed loop control, and this capture scope. The last widget is remaining. Uh, this is the slider or the digital display. So for digital display, what I need to have, I'll simply take this digital display for the V in, and I will take for V in. For its updated, I'm taking 250, and to an analog signal is simply I will take V in. V in. Okay. And the last, very last widget is the slider. I would like to have a slider with me. This one. Okay. And in this slider, this is we are taking the value in the per unit. So I'm just writing it as input voltage per unit. Okay, and I want it to take from 0.80 to 1.20, say for example. Okay, and the step size, say for example, here I'm taking 0.0202. Okay, and in edit in core editor, what I want to do is I'm just I just want a variable I'm defining here. Voltage is equals to 35 into input value, and again here we will go into the source setting and insert this hill dot set constant value v in, and the value will be here is voltage instead of input value. So fine, save it and close it, and now it's a time to save. Actually we have not saved this panel, so let me check with what name I have saved the SCADA schematic boost adv c2. Okay, so I will save it as in this folder only, boost adv c2. This will the cus panel cus file, and save it, and now just run it and give the value like as 35 here I'm giving. Yeah, this is basically what we are just giving the input. We are varying our input. We can vary the reference voltages from here. Yeah, and you can see the output of this boost closed loop. Basically what we have done is we have designed the plant in the schematic editor of Typhoon Hill, and the controller we have designed in MATLAB. We have generated the C files in from MATLAB, and we have import all these C files in our advanced C function of Typhoon Hill, and with the help of that we are just designed our model, and this is for the capture and scope. What is happening here? Okay, nothing is coming just because I have not initialized the port. Say for example C and L I want to see here, first port V in and V out, and then I out boost. So here you can observe the results at 5. This is coming 5 millisecond. You can observe it 100 microsecond also in this fashion, in the most large way. So I'm done with my side, and if anyone of you have any problem, or someone is stuck in somewhere in SCADA and in schematic, kindly ask, or you can present your screen as well if you are stuck in somewhere. Uh, Everyone has made it, and few yeah. Hello.
Sir, I have doubt from advanced system.
Yes, yes, please.
Showing one
From
error.
where you are showing error?
Yes, sir.
Yeah. Okay. Can you please share your screen? I'm just stopping my screen.
Assignment दिखता है
I'm sharing my screen, sir, already.
Wait.
assignment है
Wait. Yeah. I have not stopped my screen.
Hello, sir.
I have not stopped my screen. Yes, please. Yeah.
Okay.
Yeah.
When I compare this, the advanced C function one
Yeah.
is showing the error as advanced C function one, like just like this.
Click on it. Yeah. Double click on its advanced function.
Yes, sir.
Yeah.
नहीं दिख रहा
Just click on the check syntax. Check syntax, right?
नहीं दिख रही यहाँ तक तो पहले
Yeah.
No errors
No,
found.
no error found. Okay. Can you please go into the
ऊपर
functions?
कौन सी है
Function tab.
Yes, sir.
वही पड़ी
Yeah, एक minute. Yeah. Fine. Okay. Okay, close it. Have you inserted the file? Just kindly double click on it once again. Yeah. Yes. Okay, fine. Completely fine. Okay, close it.
तेरे को
Close it.
चाहिए क्या
Now let's see the V out in, enable out,
इसकी अरे यार ये
modulation signal out. Okay. Advanced C function has not showing any error. And have you made the SCADA or something? What?
जैसे ये प्रैक्टिकल चाहिए होंगे तेरे को
Just kindly. Yeah. Mr. Shiva Kumar, have you made the SCADA or you are, till you are
No,
on the
sir.
schematic only?
I have not created.
और भी थे इन्होंने
Yeah.
किए नहीं
Okay. Kindly go show me this error log. Just up and kindly go for up and down.
डिप्लोमा जितने नंबर चाहिए तो बोल रहा
No, this one. Just go down window. Huh. There is also a scroll bar. Huh. Just wait. Yeah. Advanced function using one component connected to V out in. Okay.
Salim sir,
Yes, sir.
just look at the V out. I think
Yeah,
there
this
is
is what.
spelling.
Yeah. This is what he's. Yeah, V out. You have taken 0. That double clicking on it. Double click on the advanced C.
अरे आठ तो रहे लेकिन काम
Yeah,
तो
you
नहीं
have
है
taken 0. I think 0 you have taken. V out. Number one
इधर
line.
दे
One
इधर
line.
दे
No.
इधर देखो
Just go to journal. At first V out. Yeah, you have taken 0.
Okay, sorry, sir.
Yeah. Make it O.
Small O you have to take, I think. Yeah.
Yes.
So
हर कुछ उठा के ले जा रहा इधर देख
And again, it's showing.
ये मशीन का प्रैक्टिकल चल रहा है
No.
ये ड्रेस का प्रैक्टिकल है
Kindly
ठीक है
kindly
ये वापस ड्रेस का
other person,
प्रैक्टिकल है ये
please
मशीन का आ गया
switch off your mic. Someone is
स्पीकर चलो
speaking
ये
it.
भी मशीन का आ गया जो चार इसने कर रखेंगे ना वो चार इसने भी कर रखे हैं
Who is
उसके अलावा
speaking?
इसका
I don't
एक्स्ट्रा
know.
कुछ नहीं है हाँ रूम पे ही आ
V
जा
out. Real unsigned.
Again, it's showing the same error.
Click on advanced C function.
Okay, sir.
No, here the components, the console message is given advanced C function. Click on that.
Yeah.
Yeah. Yes. Okay. The problem is coming be out. Mic open कर लो.
Double click on the advanced C function.
The problem is creating in.
Kindly go to the functions. You have taken 0 might be possible into that functions. Yeah. V out. Now you have taken right here 0 OUT.
Check the plant diagram. I don't
show you a plant. Yeah, just okay. Up scroll. V out is also yeah. It's fine. V out is good. ठीक है.
Make the connection of V out correct. I think it is intermingled with the other connections, so that's why it is showing now in
No,
the end that it has more than one input connected to V out.
yeah, yeah, you are right, but it is correctly.
It's connected to enable also.
Huh?
Enable of boost converter.
It is also connected to enable of. So delete first, delete it, and then connect V out. Yeah, delete it. Yes. Yeah,
Yes,
delete it.
yes. Click on delete.
Delete. Yeah.
Delete button. Delete key.
First I have to select.
Yeah, it is selected. Delete. Select.
Press delete, please.
Yeah.
Yes.
Now connect. And here V out is also delete from this side. Yeah, it's also delete. Yeah. Now V out is connected to V in advanced C function. Yeah, it's okay. Yeah, it's okay.
Now compile.
Now compile. Execution rate is problem.
Yes.
So initialize
He has not
TS.
mentioned execution rate.
Yeah.
Model initialization. Yeah, go
Yeah.
top.
Right.
Yes,
Yeah.
yes.
Right side. No, not
Left
left.
side.
Yeah. Double click. Yeah. Here TS is
50 microsecond. 50
no
E minus
capital
6.
T. Yeah.
Yeah, TS equal to 50 E minus 6. E small e minus 6. Yes. Okay. Run it. Run it.
Same.
Okay, just go to V out. You have not mentioned the TS over there, and you need to mention the no, the voltage measurement in the plant. Yeah, this V out, the right side of the boost. Yeah, click on it. Signal processing. Okay, you have mentioned TS. Fine. Okay.
Compile and reload again. Yeah, compile. Yeah.
You have not compiled.
No, compiling. It is compiling.
Compiling what?
It is compiling.
Error.
Compiler.
As you can edit X and
Check execution rate at some other component, I think.
yeah. Click on the very first this I input near to V input. No, that's fine.
Boost converter. Click on boost converter. Yeah, double click.
Not
TS.
there.
Yeah, TS.
Yeah,
Execution rate is
execution
TS.
rate taken as TS.
Very last.
Yeah, very last. Yeah. Take as TS.
Now run. Okay, run it.
Okay.
Click on it.
That will be inherit only, that boost one. The problem is coming in is SCADA, which is connected to advanced C function. Please check on the SCADA. Their execution rate is not correct, I think.
Yeah.
Check both the
Reference.
SCADA and make the boost converter the execution rate inherit only. Make it inherit and check the SCADA portion, because that is going as an input to the advanced C function.
Yes, I'm sure.
And this one.
Yeah,
this one and
Click
PWM
on
both.
reference and PWM.
see here your execution rate is different.
Take as TS.
And keep boost converter as inherit.
No, कर दिए.
नहीं, boost converter. Yeah.
Okay.
Boost converter.
Double click on boost converter. Yeah.
Inherit.
Yeah, it's okay. Now compile and reload.
We need to be very careful while designing the schematic. We need to take care of the execution rates, and the variable we are defining, they all are case sensitive.
Yes.
So Compile and interrupted was error. Now XTU has no member. XTU has no member name reference. Kindly, could you please read it out for us? XTU has no member.
XTU has no member named reference underscore in.
Double advanced C function. Go to advanced C function. Go to functions. XTU. You have mentioned something here or what?
Just
RTU.
close the error, show me the error once again.
RTU dot reference equal to reference. Yes, second line is correct.
One second, just checking.
XTU has no member named enable. Error.
It is extra. It is talking about the external input.
Sir, maybe input name in advanced C will be different.
Yeah, it's some naming is different here. Capital R is taken here, and here small r is taken. Might be, it may be.
Yeah, please check for the naming because this is talking about the external input. So of course, in the advanced C function, maybe names you have taken wrong.
Double click on advanced C function.
No, it is correct, I think.
It is correct. Yes.
Compile and go ahead.
Okay, fine. Compile.
Click on go to reference block. Go to reference block. Yeah. Yeah, it is connected to Pro enable.
Check this spelling in the from block also. Global. Check both of all four are global.
I have to change that capital R.
Yeah. No. Here, whatever you can take. If you are taking in the small r in go to, so you have to take in small r in the from also.
Yes.
That is no issue. You can take it as small or capital R. But if you are taking enable as small e of from, then you have to take in enable small e in the go to also. Okay. So for that, and we need to check your model. You have done a small
Hold
mistake.
on, click on SCADA. Click on SCADA. SCADA reference input which you are giving. Just check the parameters. It is real. Okay, fine.
Yes, fine.
Then the inputs which you are giving to the boost. I think Salim sir, if nobody else is having the query, so they can leave the session and we can continue with this query.
Yes. Yeah, let me
Relieve
request
others.
to. Yeah, I request Vivek sir, Manoj sir, anybody is there?
Yes, sir.
Sir, actually we have done from our side and all the participants have done their part. Only one candidate is facing the problem. So we want that he should present here and rest can leave. We can just resolve his query in 5 to 10 minutes. We are looking what mistake he has committed.
Sure, sir. Every
Okay.
participants, yeah.
And we will be meeting again at 2 p.m. at in that session we are going to design and simulate the induction motor closed loop control, and we will take how to deal in the electrical drive sections in Typhoon Hill. So we will be looking in that in the second half at 2 p.m. We will be see you again. Okay.
Steve Kumar,
Yes, sir.
have you any query? Otherwise, please lower your hand.
Excuse me, sir.
Yes,
I
yes,
have
please.
that my on the boost converter there is EN and IN, right? Enable
Sorry.
on the boost converter. There is enable and reference, right?
Yes, yes.
So my own is showing me the arrow from enable is going in. Why?
Yes.
I'm confused. Arrow from enable is going in.
Yeah.
But arrow from enable should be going out, right?
Yes.
Just click on the advanced C function. There is problem in your reference input.
Okay, how to change it? Because arrow is showing me from the enable and
Actually, can you please present your screen?
Okay.
Yeah. This is another screen. This is another guy's screen.
Okay.
Yes.
This
Shiva Kumar, please.
Yes, sir.
Yes. Yeah, you please stop sharing. Then I'll look at your query. I'll come to you. Just give me 5 minutes.
Okay.
Now.
Can you see
Yeah,
my screen now?
yeah, I'm able to see your screen. Mr.
Okay,
Abalawan. Yeah.
It's showing me. You see this one now. Go to. Is it from right? Supposed
No,
to be
at the top here you have to take the from block from.
Okay, from block meaning this one, right?
Yeah, this one. Just click on it and make it reference. Write it reference.
Okay, yes, that is why I am having problems. So
Yeah,
reference,
type it reference and make it global.
Reference. This one should be global. Then okay.
So make it local. Just make it global.
Okay.
The double click on it. Make it global. Have you done it?
Yes, I've done it. Global.
Yeah. Another take one more from block from tag signal tag from one more.
Okay, this one right again.
Yeah, you connected this and yeah, right. Yeah, very good. Yeah, click, make it enable and make it global.
Okay. So delete.
Okay.
So this one now.
Yeah, connect with this EN terminal.
Already connected. Which one? Yes,
Yeah,
connected.
yes, correct. Now go to advanced C function. Come down, advanced C function. Come down.
Okay, advanced C function. Okay.
Yeah, come down. No. Just close it. Show me your advanced. Yeah. Yeah, it is right. It is right. It is. You have taken the go to block na here. Yeah. Right. Now what's the problem?
I cannot validate it.
No, it's fine. It's fine.
Yeah, it's showing me evaluation fail for the property execution rate boost converter.
Okay. Just click on your boost converter.
Okay, click. Should I change it to TS or what?
So here put I is a capital, but here I should be small. So put inherit in small. Yeah.
Which one here?
Yeah. Starting the capital. You have put it the yeah.
Okay, I small.
Yeah. Put is small.
Okay, small now.
That time period. Take that time period is 1 microsecond. 1 e minus 6.
This one.
That time period.
And offset error is yeah. It's okay.
1 e minus 6. Okay, done already.
1.
Okay.
Okay, and compile it.
It should say me execution failed for the property execution.
Now run it once again. Run it once again.
Component out, okay. Still V out.
Run it.
V out execution. Okay, run it again.
You have run it?
Yes.
Compile it? Okay,
yes,
okay. Okay, fine. What is showing now? What is showing now?
It's showing me execution failed for the property execution rate of the company V out.
Okay. Have you initialized the execution rate at the top of the model TS? Top.
Which one? Top?
No. Just close it. Yeah, top.
This one? V.
At the top. At the top, where you are compiling, reloading, and that the left side. There.
Okay, left side of the compile button.
At the top.
Left side of the compile button.
At the top of your screen.
This one?
No. The
yeah.
button.
Just right. Left side.
Validate model or what? This one?
After the setting icon.
Before
Left
the
side,
setting icon.
yeah.
Yes.
One more. Left
This
side.
one?
One more. No, left side. Why you are going to right side? Go in the left side.
Okay, this
Second.
one?
No, sir. You go left side.
Is it model
Yeah,
initialization?
yeah.
Model
Double click.
initialization script?
Yeah, double
Yes, click on it.
Okay, click.
Yeah,
Yes.
airport TS is
Mention capital T, small s, TS equal to
Okay, equal to.
TS equal to
Okay.
type 50 microsecond, 50 E minus 6, 50.
5, okay, equals to 550 microsecond, right?
Yes. Equals to 50 microsecond, minus 6. Yeah.
Okay, minus 6. Minus 6, right?
Yeah, minus 6, not 3.
Okay, thank you.
Yeah, okay. Click OK, run it once again.
Yes, now it is running now.
Now run it.
Yes. And then, sir, my next question is.
Yeah, let's just let it finish. Finish the compilation. Then we will come to your next query. Let's see, is it error free or not?
Now it's compiling.
Yeah, now. Okay, fine. Let's compile once again. Let it complete first.
Okay.
But sometimes it shows error at the very end stage.
Oh.
Sometimes it's in very rare case, but it shows sometimes.
Yes, still error. RTU on clear.
That is what I was saying. RTU undeclared line 359.
double click on advanced C.
RTU you should be capital. In RTU
Yeah.
you should be capital. Just kindly go into the advanced C function and make the necessary correction. Make U in the capital.
Okay, all U should be capital, right?
In the function.
Oh, this one actually is capital, right?
Yeah, just go to function. Yeah.
Okay.
Yeah, third. U should be capital.
Already finished. This one.
No, check everywhere where you have written RTU. This R and T is in small and U should be in capital.
I have already replied all.
Okay, fine. 1, 2, 3. Just check it somewhere like bit.
I think line 3. Only line 3. Only
line 3.
Yes.
So you have done the correction?
Yes, done already.
Yeah, okay. Just save it and run it once again.
Okay, control.
Make it okay. Okay, click on okay.
Okay.
Yeah. Run it once again.
Okay, it's running. It's validated now.
That's what I have said. Sometimes it shows that at the end. It compile line by line, and sometimes it show error at the end if you are having the error.
Still, extension Y has no member modulation signal. Please make the needed correction and restart the compilation.
Yeah,
Check
you have
spelling of modulation.
Modulation spelling is wrong.
Okay,
Just
modulation.
Yeah, just go to advanced function.
Yes, I've seen it. Modulation is wrong. You are right.
Click on the function.
Yes, modulation. Yes, this is the correction. I saw modulation.
Yes.
Sorry for wasting much of your time.
No problem. We are here to help you out. Have you done correction, modulation?
Yes.
Yeah.
Already done. Now I'm compiling again. Finish, sir. Successful now.
No, just let it on. Now successful. Congratulations. Yes. You have made a correct model right now.
Thank you very much, sir.
Now, what's your next question? Please come up.
Sir, my next question is that is it compulsory to let's say have your own this with guard. Is it compulsory?
Sorry, what compulsory? What are you asking for the compulsion? I'm not getting you.
No, you made some this wizard widget, right? This display button that you made earlier. Is it
In SCADA,
compulsory?
in SCADA?
Yes. Is it
No,
compulsory?
actually, no, nothing is compulsory. It's all up to you. What type of widget you want to take, what type of panel you want to create, it's all up to you.
Okay.
Like, yeah, it's like only for this particular model, only the gauges like V out and I out is okay. You can give the input from the model control of V input just to decorate the panel and to show the electrical glimpse. I have just decorated likewise as it is available in the example. It is not
Okay.
necessary to place all those widgets which I have placed. It's all up
Okay.
to you. As per your requirement, you can place the widgets and you can modify according to them. Okay.
Okay, sir. Okay, sir.
Yeah.
Thank you very much, sir.
Okay, your all question has been answered.
Yes. Thank you, sir.
Okay, now you please stop sharing your screen, and that guy who was having the problem, please share your screen.
Okay. Now I've stopped sharing.
Yeah, you please stop sharing your screen. Another guy, I just forgot, Mr. Shiva Kumar is there.
Yes, sir.
Yeah,
I'm
yeah,
sharing
yeah,
my screen.
yeah, yeah.
That error was gone, and then another error came.
Yeah,
That
which one?
modulation signal out is undeclared. Saying.
Okay, modulation signal out. Just check the spelling of that modulation signal out. Uh, Go to function, modulation signal out. Wait, let me check. Underscore signal out RTY. Yes, you're correct. Modulation underscore signal.
Salim sir,
Yes,
in
sir.
his C function, try look at the additional sources. I think some file
Okay.
is missing here.
Kindly go to additional sources. Oh, the additional sources has all the file. Click on this button, which is arrow button. No, just arrow. No, no, here only. Yeah, yeah, yeah. This one. Yeah, all the three files you have. Close it.
Go into general function, general,
Very first line.
general, and then output here. Yeah, here.
Capital S. It should be capital S.
Yeah. Signal,
Modulation
signal.
signal out. No, 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 no,
No,
no.
here, no, here, no, here. In general, and then output. Yeah.
S should be capital. Modulation signal out. S should be capital. Yes. Okay. Compile. Just wait. It is getting compiled, and I hope it will run this time. Yes, it's fine. Okay, so your model is also become error free right now. So now you can proceed with the SCADA, as you can able to see with the help of the example, as it is available in the example. You can take the help, or you will have the recording from Dr. Vivek Srivastav. He will provide that recording to you.
Okay.
You can watch and you can have a look. And if you have any more query, please ask. Then otherwise we will then shut down.
No, sir, it's okay.
Okay, fine. Okay,
Yes.
fine. Then if I think most of the people has left already left, and if any other participant if has any query, kindly ask. Or we are just signing out right now, and we will be meeting out just after 1 hour at 2 p.m.
Okay.
Okay, so shall we leave? No.
Yes.
Shri Ninja Shastra, shall I share my screen? What's your problem? Shri Nanjani Shastra? Yes. Shri Nanjani Shastra. Are you able to hear us? Shri Nanjani Shastra, are you able to hear us, or you want to share your screen? Hmm? Okay, but your voice is not coming to us. Please unmute yourself.
Am I audible?
Yeah, right now you are audible. Yes. What's your problem?
Sir, I'm getting error.
Yeah. Please show me your screen.
Yeah, is it visible, sir?
No, not yet.
No, not visual till now.
Kindly click on the fourth icon which is available on your computer screen. That is like open share tray. And after clicking on it, there is a icon of desktop. Click on it, and it will show to us.
Yeah.
Yes. Now, what's the
It is
problem?
visual.
XTU has no member named enable. What you have done? The same problem you must be facing. XTU has no member named enable. Just click on advanced C function. Yeah, click on advanced C function. Yeah, let me check. Journal input V out. Okay, reference. So PWM and enable in. Output. Go to output. Output. Go to output tab. Yeah. Enable dot out modulation signal out. Okay, fine. Okay, variables. I think there's no variable. Okay,
There
there's
is
no
no
variable.
variable.
Now go to functions. Go to functions. RTU dot score in RTU dot. Yeah, third line. Third line you have to write RTU dot PWM underscore enable. Line number third. Yeah. PWM underscore. Yes, PWM underscore. Let me check once more.
And at line 6,
And just
enable.
click it once again. Click it. Yeah. Shamshir sir, you were telling something.
At line 6, use small e for enable. RTY dot small e enable.
Yes. He's right. Line number 6, enable small e.
Yes.
Make it small e. Yes. Okay, and run it. Let's check. Hope it will run this time. Actually, once you go to this software and once you practice, then this type of error will not come. Sometimes we make errors like small and capital because these are case sensitive. Now, somewhere you are just mentioning signal as capital, and somewhere you're mentioning small. So, like, it creates problem. So, let it run completely.
Yes.
Yeah. Until and unless, yes, until and unless it shows compilation successful. Yeah. Your model is also now error free. You can load your model on the virtual hill right now, and you can proceed with the SCADA as it is available in the example. Okay.
Okay. Thank
Okay,
you so
ma'am.
much.
Is there any more
Thank
query?
you.
Okay, you're most welcome.
No, sir. Thank you
Okay.
so much.
Okay, dear participants, now we are signing out and we will be meeting at 2 p.m. once again. And still, if you have any more query, you can note it down with you and you can share with us in the next session. Till then, we are signing out and see you at 2 p.m. sharp. Thank you so much. They've already